All right, so 6.1, right, we're talking about exponential functions. So we've been doing stuff with exponents, and we talked about properties of exponents and how to deal with those. But now we want to talk about these as a function goes. So this is kind of the general form of an exponential function. So if you have f of x equals, well, usually I have like a times b to the x power. Right? Sometimes our a is just 1, and so we just have that b to the x power part. But this is just kind of the general form of exponential functions. All right? So if you're asked to, so our first example here is going to ask you to evaluate f of x equals 2 to the x power for f equals 3. So remember, when we have something in this function notation, that's telling us to take that number and put it in place of x. Right? So we're putting that 3 in place of x. So if I'm evaluating this, then it's really going to be 2 to the 3rd power, which is 8. Right? So f of 3 for this function is 8. And we talked about a little bit about this notation too before, but I want to re-emphasize what this means. So if we say f of 3 equals 8, this is telling us an ordered pair, a point on the graph if we were to graph this function. So this is saying it would be the ordered pair 3, 8. So when x is 3, y is 8. Right? So it's giving us this point. Right? But you don't need to put it in this as an ordered pair unless it asks for it in that form. A lot of the times on the homework, it'll just ask you to put the 8 in there. But I want to make sure it's really clear what you're trying to find here when you're doing these. Okay? All right, so let's try this next one. So for example 2, still want you to evaluate. Okay, and you're going to use the function g of x equals 3 to the x power. Right? And then there's going to be some different parts on this. So for part A, I want you to find g of 2. Part B, I want you to find g of 0. And part C, I want you to find g of -4. Okay, so go ahead and take a minute and do that, just kind of like we did on example 1. But now, do it for these 3 different x's. Okay, so on that first one, you're just putting 2 in place of your x, right? So 3 squared equals 9. Right, so that one's not too bad. On the second one, you're putting 0 in place of x, so 3 to the 0 power, right? Anything raised to the 0 power, you got to remember, is 1. Right, but this one, I want you to put the answer that you got for part C into your chat box. Don't hit enter yet. Okay, I'll tell everybody to do that at the same time, but go ahead and get that put in there. What did you get when you found g of -4? What is g of -4? Type that into your chat box. Remember, if you can't find your chat box, if you go to the top of your screen and you kind of hover over, with your mouse, you'll kind of see a drop down that comes up, and there will be something that says chat and something that says participants. So those are the two boxes that you want to make sure are open. And sometimes they're hidden. All right. Everybody have yours in? 3, 2, 1, press enter. Awesome. You guys are doing really good. All right, so looks like you're saying 1 over 81 is what you got for your answer, right? Because you're putting 3 to the negative 4th power. And when you have a negative power, that's telling you to flip it, right? So it's kind of like this is over 1, and we're going to flip that. So 1 is on the top, and then 3 to the 4th power is on the bottom. Right? Once we flip that, that exponent is no longer negative. And so we get 1 over 3 to the 4th power is 81. Okay? And if you write it as an ordered pair, right, then the x part is negative 4, and y is 180 over 81. Okay? But awesome job on that. Right? Remembering those negative exponents don't mean a negative number, right? It means a fraction. You're flipping it whenever you have something like that. What questions can I answer on those examples?
Hi, this is Ellie.
Hey!
So I've been having like a bunch of glitches like happening, so I've like missed quite a few things you've been saying.
Really? Okay. Hold on for just a second. You know what? Let me go make sure that nobody's streaming. Are you guys all having that problem? Like, raise your hand.
It might just be me. I have really
well, it could be on my end because my last
internet.
class was saying that happened every now and then. But raise your hand if you're still if I'm glitching out or if you can't hear what I'm saying. Okay. All right. So what part did you miss?
Where did you get like those numbers, like 3 in example 1? Like where did you just like come up with that, or like I'm just confused like on how you got like the power.
So let me mark. This is what is given to you. This is what the question is going to say.
Oh,
right?
Okay.
And so you're just putting that 3. So that's given to you. Put it in place of the x, and then you'll find the 8.
Okay. Oh, okay.
Does that make more sense?
Yeah,
I know. Sometimes it's hard to tell. Like, you're like, okay, wait a minute. What's the question? And what part are you just, are you just pulling numbers from someplace or what? So
yeah, I had to switch off my computer and download the WebEx stuff on my phone. It's a lot better there. But
oh, good.
My computer is like doing crazy things
stuff. Oh, no. I know. It is crazy right now. All right. Good question. Is there any others you have on that? Okay, let's look at, we're going to still evaluate on example 3. And this one looks a little bit different, but it's still the same idea, right? So we're given the function. Let's see. So I want you to evaluate, and evaluate just means find the answer, right? Find the numerical answer. F of x equals 1/2 all raised to the x power. All right, so now we have this fraction raised to a power. All right, and then I want you to try again. This is going to have 3 parts to it, so I want you to find f of 1. I want you to find f of negative 1. Oops. And find f of negative 2. Okay, so try those 3. Okay, so on part A, you should have just come out with 1/2, right? Because whenever you raise anything to just the first power, it's just that same thing back, right? So 1/2 would be your answer on part A. On part B, where you're raising it to a negative exponent, that's telling you to flip everything inside, right? So we really have 2/1, right, raised to the first power, right, which really is just 2. Right? Because that negative exponent is telling you to flip it, right? And then the last one is also a negative exponent, but it's to the -2 power. So again, let's flip everything inside, right? So we have 2/1. But now, instead of being raised to a -2 power, it's now raised to a +2 power. So you really just have 2 squared, which is 4. And 1 squared, which is just 1, but we don't need to have that 1 on the bottom. So our answer would be 4 on that one. All right, so you're just kind of, substituting these in, but trying to keep in mind those properties of exponents that we talked about, because those are going to come in really handy on a lot of these that you're going to be dealing with. Okay, let's look at another one, just one more evaluate one. This one might look a little bit different. So now our function says f of x equals 5 to the x minus 2 power. Right? And so you're going to have some things like this, these functions, and the next thing that we're going to be moving into is how to graph these kind of functions. And so it's important to know how to choose some x values that would be really helpful x values. Okay, so as we're evaluating these, I want you to think about, why, the ones that we're looking at would be good ones to look at. So I want you to figure out what f of 1 is, and then I want you to figure out what f of 2 is, and let's do f of -1. Right? So again, if I put 1 in place of my x, that means I'm going to have 5 to the 1 minus 2 power, which is 5 to the -1 power. Right? And so that's telling me just to flip it. So that's going to give me 1/5 for my answer there. All right. Now let's put 2 in. So when we do this one, we've got 5 to the 2 minus 2 power, right, which is just 5 to the 0 power, and anything raised to the 0 power is just 1. Okay, actually I'm going to do another one inside here, so maybe I'll make that D. Let's do f of 3 also, so we can kind of see what happens on this one. So if I do 5 to the 3 minus 2 power, right, that's going to give me 5 to the first power, which is just 5. And then when I do this -1, right, so I'm putting -1 in place of x. So I'm doing 5 to the -1 minus 2 power. So I've got to add those negatives together, so I get 5 to the -3rd power. Right, and then remember that that is telling us to flip it, right, because we could say that's like all over 1. So we'd have 1 over 5 to the 3rd power, and 5 to the 3rd power is 125. Okay, those are kind of what we come up with for our answers there. So even though this one looks a little bit different because we were doing stuff to the exponent, right, that's we were adding or subtracting things to that exponent there, but we're still following the same format, just simplifying that up, using the properties of exponents to help us simplify these more. Okay, and notice one thing that happened here. I want to point out a few of these things. So when we put 2 in, right? So if we're looking at that negative 2, so if we put the opposite of that number in here, notice that it gives us that 0 power. And anything raised to the 0 power is 1. So this is usually like, so this next thing that we're going to be going on to next is graphing. So I just want to point this out to you because it's good to always start with whatever is going to make your exponent go to 0, right? When I put 2 in there, 2 minus 2 is 0. And then you want to pick things that are around that. So 1 and 3, you know, and maybe, you know, a few more in each direction, depending on how much you need to be able to see what the graph of this looks like. Okay. Questions on evaluating that example 4? Okay, let's look at some graphing then next. So example 5. Oops. So this one's going to say graph the function f of x equals 2 to the x power. All right, and remember that really just means y equals 2 to the x power. But we write it as that f of x, just telling us it's a function. And so that's just telling us that, that there's special things that we can do with it. But if it's easier for your brain just to rewrite it like this, then do it like that. Okay? And then you want to pick some values. So they're not going to tell you now. That's all they give you. They just say graph that. And they want you to pick some x's and figure out what the y's are going to be. Try it like this. All right. And so we're going to put it into that 2 to the x power. Right? So this middle portion here is just places where I can like do a little bit of work if I need to. Okay. So remember that I said I want to pick it so that I want to know when this is to a 0 power. Well, on this one that's pretty easy. That just means I need to pick x to be 0. All right, so when I pick x to be 0, 2 to the 0 power gives me 1. So y equals 1. Right? Anything to a 0 power is 1. All right, so now we want to pick things around that. So I want to pick a negative 1 and I want to pick a positive 1 and see, right, if that's going to be enough information or if I need to maybe graph a couple more points. But we'll start with this. So let's put negative 1 in. So if I do 2 to the negative 1 power, right, that just flips it. So that gives me 1/2. Right, when I put 1 in place of my x, I get 2 to the first power, which is just 2. Okay, and let's do another one in each direction. Remember, 0 is kind of like our center point, and we're trying to pick things around that. So let's also do negative 2 and positive 2. So we can see, so this graph has a few more points on it to work with. So if I put negative 2 in, so 2 to the negative 2 power, right, is telling you to flip it and then square it. So that will be 1/4. And I'll write it out that way. So that would tell me that, so that's really 2 over 1, right? Sorry, what did I do there? Let's try this again. Ah. All right, so 2 to the negative 2 power is telling you that you're going to flip it, so we're going to have 1 over 2 to the second power. And then 1 to the second power is 1/4. And then if we put 2 in, well, 2 to the second power is going to give me 4. All right. Okay, so let's just plot these on a grid here. Try and make a handy dandy little graph. All right. Okay, so let's try and see what we can come up with here. So this is the point, right? We put 0 in and out came 1. So we've got the point 0, 1. Over 0, up 1. Let me do this in a different color. will be here. Right. Then my next point is -1, 1/2. So over -1, up 1/2 might be about there. And on your homework, you're not going to be able to graph something like with halves and stuff. So I'm going to show you what you're going to need to do on this. All right, you're going to, but for the sake of this, that's just where that would be at. Our next point would be 1, 2. So over 1, up 2. And then -2, positive 1/4. So over -2, up 1/4. And then 2, 4. Over 2, up 4. Whoops, I go too far. All right, so it's going to be something, and notice, and it might not be clear to you just looking at the graph, but this line here, this part of the graph, is just going to keep getting closer and closer and closer to the x-axis, but it's never going to touch the x-axis. Try this again. Oh, goodness. Erased more than I wanted to here. Okay, so have something that looks a little bit like this. Okay, and this is going to keep going up and out. Well, kind of went out extremely far there, but so this one's getting close but never touching the x-axis. Okay, and that's because there's an asymptote here. So it's getting really, really close to it, but never going to touch it. Okay, so think about if you're standing, just a certain distance away from a wall, and you said, okay, I'm going to go half the distance to that wall. And you did. And then you do that again, half the distance to the wall, half the distance to the wall, half the distance to the wall. Are you ever going to get to the wall? What do you guys think? Somebody just unmute yourself and tell me what you're thinking. Would you ever get to that wall if you're going half the distance to the wall each time?
No.
Why not?
Because if you take half the distance, you can't take half of 0 because it just 0 is 0, so there's no such thing as half of it.
Yeah, and if you're always just, going half the distance, it's going to look like you're there. Like this graph looks like it's right on the x-axis, but it's not. It's just really, really, really close. It's getting closer and closer and closer, but never touching it. Okay, because it's just going, it's like half the distance each time, getting closer. Okay.
Is there at any point, does it start going back up on the negative side?
It doesn't. That's a good question. So this is just going to keep going, almost like following that x-axis. I mean, it's getting closer and closer and closer to the x-axis every time, but it never touches it, and it never turns around and goes back up. Okay, good question. So exponential graphs always are going to have, this kind of a shape to them where it's like this and then it's going up. Okay, and you've probably seen, things, especially with the coronavirus and stuff like that, and they're talking about how it's growing at an exponential rate when you're looking at graphs. And even if you, looked at, won't put that arrow on there quite yet, because you probably see how it's like, it's like starting off really, really slow, but it is going up gradually, and then all of a sudden it takes off and it starts getting really steep, right? So it starts off slow and then gets really steep as you're looking at that from left to right, right? And so this is exponential growth when we have something like that. And maybe write that down next to it. Come back to this idea of exponential growth. All right, so that would be your graph of it, but on your homework, it's just going to ask you to pick 2 points. So it's going to have, like, in a little box, you'll see there'll be like a little exponential curve down here, and you'll click on that box, and then you'll click on 2 points, but those 2 points need to be points that don't have any fractions in them. So like I could click on, so this is always a good one to click on. So that's why I want you to start off with, you know, what makes that exponent 0, because it's going to give you that point. And then this one also, right, was an exact point. And so if I clicked on those 2 points, then it would just make the curve the rest of the way on there. All right, so if you're struggling with some of the graphing on there, just reach out to me and let me know what issues you might be having. Okay, and remember, tomorrow evening I have my online office hours too. So if you get in and you try and do it and you can't, you know, if you're having some issues, you can come there and I can help you there also. Okay. All right, let's look at another one. So that's how we graph these exponential functions. And so let's graph another one. And this one I want to graph is, so graph g of x equals 1/2 all raised to the x power. Right? So the whole thing is being raised to the x power. So again, I'm going to make my table of values, and I need to pick my x's and figure out what my y's are going to be. But if it's helpful, I can kind of make a little workspace in between here. Right? Some people find that helpful to have that, and then they just put the, you know, what it is, what they're putting their x into. All right, so what would be the first point I would like to pick for my x? So the first x value I'd want to pick. Somebody tell me?
0, maybe, or 1.
Yeah, 0 is perfect. Remember, because I said I always want to pick my first value so that my exponent goes to 0. And so that's what this one's going to be. So 1/2 all raised to the 0 power. Anything raised to the 0 power is 1. All right, so we found a point, 0, 0, 1. All right, and then we want to pick points around that one. All right, so maybe we want to pick 2 that are smaller, so -1 and -2, and then maybe 2 that are bigger, +1 and +2. Wowzers. Struggle is real here. All right, so go ahead and finish those up. I want to see what you come up with for some ordered pairs. Okay, check your answers with what I have on the screen and let me know if you have some questions about how I got any of those points. And then I'm just going to plot these points on the graph, right? And I want you to notice what's happening with this one, how it's different than the other one that we had, right? There's some similarities, but there's some differences too. So 0, 1, and then let's see, over -1 up 2 would be there. And then over -2 up 4 would be here. Over 1 up a half, and over 2 up a fourth. All right, so this one, right, is going out, it's getting closer to the x-axis as it's going out to positive infinity. Right? Can you see how it's getting closer this way? And then it's going to take off. Right? It's kind of going up in this direction, like this. Ooh. Okay. So that 1/2, right, if we're comparing these two graphs with each other, you can kind of see both of them, this is exponential growth, so as you're looking at it from left to right, it's increasing, and as you're looking at this one from left to right, it's decreasing. So this is exponential decay, is what we call it. And so what is making that happen? Well, having a number here that's a fraction, a number that's between 0 and 1 is going to make that exponential decay happen there. All right, so let's just draw another little picture here. So things with this kind of a shape to them, all right, are functions, but these are going to be exponential decay. And again, that's because as you're looking at it from left to right, and it's going down, but it's going to be getting closer and closer and closer to an axis, or, well, a certain line here. It doesn't have to be the x-axis that it gets close to, right? But that's what's happening in this case. Okay. All right, questions on those two graphs and how to graph those? How to be able to tell when something's exponential growth and when something's exponential decay? I can look at this and see, oh, this number here, right, that's being raised to that power is a number bigger than 1. And so that's going to be exponential growth. Where if that number is a fraction, it's a number between 0 and 1, then we're going to have a graph that looks like this with exponential decay. All right, let's try another graphing one and see what you guys can do with this one. So I didn't need to do that. All right, so everybody try this from start to finish. Remember kind of the little hints that I gave you about doing this. Okay, so I want you to graph f of x equals 2 to the x plus 3 power. Okay, so I want you to pick your x's and figure out what your y's are going to be, and then graph it. I want you to pick 5 x's. Okay, and I want one of the x's that you pick to be 0. And I want you to have you, when you find the answer to this, right, write it as an ordered pair, type it into your chat, right? So when x is 0, what is y, right? Don't hit enter yet, but let me just make sure everybody's kind of with me. So write it as an ordered pair. What are you going to get there? All right, are you ready? 3, 2, 1, hit enter. Awesome. Okay, so it looks like most of you are saying 8, right? Because when you do 2 to the 0 plus 3 power, that's just 2 to the 3rd power, which is 8. Okay. Now that's not necessarily the number that or the x that I'd want you to start with, but that's one of the ones that you should have, that you probably have on your graph anyway. But remember, I said the number that I want you to start off with picking is whatever is going to make our exponent go to 0. So I want to choose -3, right, as my x value, because that's going to make my exponent go to 0. And so then when I put it in, I've got 2 to the -3 plus 3 power, which is 2 to the 0 power, which is 1. Okay, so see if that's one of the points that you came up with also. And then I said pick some numbers that are close to -3. All right, so maybe you want to choose -4. Maybe we want to go the other direction and pick -2, and maybe -1 or something. There's a lot of different ones that you can pick on here. All right, and then we'll have to see if that's going to be enough. When we're drawing it out, we need more points than when you're doing it on your homework, because your homework just will take 2 of the points, and it has an exponential curve already created into it, and so then it will graph it on there for you. All right, but if we put -4 in here, right, so 2 to the -4 plus 3 power is 2 to the -1 power, right, so that's going to give me a 1/2. All right, if I do 2 to a -2 plus 3 power, that's going to be 2 to the 1st power, which is just 2. And then if I put -1 in, I get 2 to the 2nd power, right? -1 plus 3 is +2. 2 to the 2nd power is 4. All right, so here are some points that I have, and maybe it's going to be enough to see what this looks like. All right, so I put 0 in, right? I got 8, so over 0 up 8 is there. Oops, do a different color to see. All right, and then I have -3, 1, so oops, I need another this way. I forgot I was going more this way. All right, so I've got -3, so I put -3 in, and I go up 1. Right, and -4 up a half, and -2 up 2, and -1 up 4. Right, and then 0, I had 8. And if I went over 1, right, then I'd have 1 plus 3, which is 4, so 2 to the 4th power would be 16, so I'd be clear up there. Right, but we can see that this graph is looking something like this. Right, and again, it's getting really, really close to that x-axis. Right, and so this is exponential growth. Again, our base of this, right, that 2 is a number that is bigger than 1. And so that's going to lead to exponential growth. All right. What questions do you have there on that one? Does everybody feel like they be able to graph these? If not, let me know what question you have. If you have a question, somebody else has that same question, I am sure. So please, talk. All right, well, let's take a little 5-minute break then, and when we come back, we'll talk about 6.2. So 6.1 is basically just evaluating exponential functions and graphing exponential functions. Okay, so that's what you should know how to do on 6.1. Into 6.2 then, and this is we're going to be talking about applications. Right, so story problems, applications using exponential functions. And so there's going to be 2 formulas that you're going to need to know on this. And just so you know, in the past, these formulas have been given to you. So you don't need to memorize these formulas so much, because like on the final exam, if they ask a question dealing with this, they will give you that formula. Okay, but the 2 formulas, let's write these down to start off with, is we're going to talk about compound interest. Okay. Maybe before I write the formula here, can anybody tell me what do you know about compound interest?
Nothing.
Nothing. See, that's a very valid answer. Anybody know something about compound interest? Where do you see compound interest?
Do you see compound interest in loans? Like over a certain amount of time, it's what collects an interest?
Yeah, that's exactly right. So like credit cards use compound interest. If you have a mortgage, you're buying your house, you have compound interest. So yeah, usually any type of a loan will have compound interest in it. Okay, but what does that mean? So what is interest, first of all? Let's just start with that word, because these are kind of some businessy words. Anybody know? What is interest? How could you describe it?
Usually in loans, it's a percentage of the loan that you also pay on top of your actual loan. So basically, it's money you give back for borrowing.
Yeah.
Yeah.
Yeah, no, that's a really good way to describe it. Right? So the bank's like, well, I will loan you money, but I'm not going to loan you money for free. Right? So you're going to pay back a certain percent of what your loan was worth. Right? So maybe it was like a 3%, interest or something like that. Or 5% interest. Then you pay back not only what you owed, but like 5% more. And that's how they make their money. That's how the bank makes money on loaning out money, right? So that's and then compound interest is they're making money on the money already made or already given. So it's kind of interesting, but so when interest is compounded, it's added to the principal, and then it keeps, adding that every time. So let me write down the formulas here. Maybe that will help us a little bit more. So here's the formula. A equals P, and then in parentheses, 1 plus, R over N. right? So all of that's inside the parentheses. Raised to the n times t power. And all of these different letters mean different things, right? So, like I said, this formula would be given to you on the test, but they're not going to tell you what each of these things stand for. That's what you have to remember. Okay, so this A, just write down what these mean. So this A represents the end amount. Okay, so if we were talking about a loan, like how much you would pay over the life of the loan, including the interest. Right? The P here is the principal amount, which means your start amount, what your loan amount is if we're talking about a loan. Oops. So the principal, oops, my goodness. All right, or the start amount. All right, and then R represents the interest rate. Okay, and it's an annual interest rate is what R stands for. So it's important that you know it's annual. Annual interest rate. And some people, you've heard of APR, right? That's what that annual interest rate is. Right, and then there's an N here, and there's two N's, and both of these N's mean the same thing, and these are the number of times it's compounded in a year. Okay, and then T is the time. And the time has to be in years. Okay. Let's go back to this N for just a minute, because I want to talk about this, because this is, you've got to know some words that they're going to be using in the story problems that deal with this N, right? So if they say it's compounded yearly, then your N equals 1, right? If it says that it's compounded semi-yearly, right, then that means twice a year, so N equals 2. Right? What if it said quarterly? Oops.
Would it equal 1/4?
Not 1/4, but 4, because 4 times a year. All right?
Oh.
Does that make sense? But yeah, you're right in the parts, you know, so quarter meaning 4. So that means that, you know, every 3 months, right, or 4 times a year, that would be compounded, right? Another one you'll see is monthly, and there's 12 months in a year, so that would be 12. And then you might see daily, and for that one, we use 365, right? Because there's 365 days in a year. So kind of keeping track of some of these words and what they mean, that's going to determine what these N's are, right, in this place. And this is how, you know, how many times it's compounded in a year. All right, the other formula, I'm just going to write them both up here because there's just really 2 formulas that we're going to be talking about. And the other one is about depreciation. All right, does anybody know what depreciation means? Something depreciates, what's happening?
Like the worth of that item.
Yeah, is going,
time.
yeah, it's going down, right? So when it's depreciating, it means it's losing value, right? So one thing that, you know, people always hear about is if you buy a new car, right, it's going to lose value, you know, like as soon as you drive it off, right? It depreciates really fast, where homes usually, gain value over time. Right? They go up, but some things depreciate. And you might see this, sometimes people have to keep track of things, like if they have a business and they're trying to do some write-offs, they have to think about kind of how it has depreciated over time too, what the value of that thing is that they're trying to write off. So sometimes you'll see depreciation there, right? But the formula for this is V equals P times 1 minus R raised to the T power. Okay? And so remember, V here is going to be it's still kind of our end amount, but because we're talking about depreciation, it's our depreciated value. Right? P is still our principal, right? The amount that it starts off with. So we'll call it the original value. Right, so like what you bought your car for, right, would be the original value. After a certain amount of time, right, you would have the depreciated value. Right, R again is the interest rate. And then T is again our time in years. Okay. So understanding these two formulas, right, and what each of those things represent is going to be a big part of being able to do the homework for 6.2. And it's just kind of interesting. Remember, compound interest isn't always bad, right? If you're paying a loan, yeah, then compound interest is bad. But if you put money into an account and you're gaining interest on that money in your account, right, then it's actually good to have compounded interest. So don't always think about it as a negative thing, right? You want to be earning compound interest, but not paying compound interest. Would be kind of the way you want to look at it. All right, let's look at a few problems together on this. And let's say, all right, so $2,000 is invested in a bank account. Right, it earns 5% interest annually. How much will be in the account after 5 years? Or no, 3 years. I'll do 3 years first. Okay. So we're going to want to use that formula, the compound interest, right? So you're putting money into a bank account. It's going to earn interest. So let me write this down here again, right? So we have A equals P times 1 plus R over N raised to the NT power. Right, so in this one, we're trying to find the end amount, right? How much will be in the account, right, after the 3 years? So that's what we don't know. We don't know what A is. That's what we're trying to find. All right, what is P in this situation, in this problem?
Be the $2,000.
Yeah, the $2,000. That's how much money you're putting in the account to start off with, right? So we've got 2,000. All right, and then 1 plus, what was our interest rate?
Isn't it 5%?
Yeah. And so remember, if we're taking, you've got to take that 5% and change it to a decimal, though, before you put it into your equation. So 5% is the same thing as 0.05. Right? Don't put in 0.5 because that would be 50%. That would be a lot of money you would be making in interest. Nobody would give you that. All right? So you have to have a 0.05. So that would be 0.05. Now, n in here, it's kind of coming from that annually, right? Because it's not being compounded more than once a year, then really on here our n is just 1, right, in both of those places. And then t is 3, because we want it after 3 years. All right, so let's simplify this up a little bit. That looks kind of crazy. And have your calculators handy here, okay? Because on the test, like on the final, usually, you know, one of these problems show up. And you can use your calculator, but you do need to show me the steps, like what numbers you're putting where, and then from there you can kind of put it into your calculator. So some of you might be able to...
Can you explain why the n is 1?
Yes, because it says annually. And it's, you know, it's not saying that it's compounded more than once a year. And you'll see it a little bit more when we do our next example, when it says it's it's 5% interest compounded, like semi-annually compounded.
Okay.
Okay, maybe I should put that word compounded in there. Right. It'll make a little bit more sense there. So it earns 5% interest compounded annually. Right, so that's why we have the ones there. And so we'll have 1 plus 0.05, oops, raised to the third power. All right, so on some of your calculators, you'd be able to put it in just like this. Others, you're going to have to do the order of operations, right, and put it in there. So here we'll add those together, so that's 1.05. And then if your calculator doesn't do order of operations, then you have to raise it to the third power and then times it by 2,000. All right, but like I said, some people would be able to just put that in your calculator. It just depends on what calculator you have. Okay, but I want you to put into the chat, right, what you got there, round it to the nearest penny, right, to the nearest cent on this. And don't hit enter yet, just enter it into your chat once you come up with an answer. I'll give you a minute to try it. All right, make sure you put in the chat. Don't hit enter yet, but everybody get your answer put in there. What would A equal? Okay, is everybody ready? 3, 2, 1, hit enter. All right, so these are the two different answers. Looks like we came up with. So 2,315 and 30 cents, right? Or 2,315.25 cents. So on this one, I said round to the nearest penny, right? So that means you do want it this way, right? This would be rounding to the nearest tenth, right? Not to the nearest penny. So make sure that, notice where it's telling you to round your answers, but usually with money, you're always going to want those 2 places after the decimal point, right? But you guys did the rounding correct on that if that's where we wanted it to round to. But oftentimes it'll say either round to the nearest dollar or round to the nearest cent. All right, the 2 different roundings that you would do on that. All right, was everybody able to come up with that though on your calculator? That's what it should have read in your calculator. Raise your hand if you need any help with that. All right, so most of this is just knowing, which numbers we're going to put where, right? That's what we got to kind of figure out here. So let's do another one. So example 2, let's try this one. So let's say this time $5,000 is invested in an account earning 6% interest compounded quarterly. So how much will be in the account after 10 years? Okay, so go ahead and try and plug those numbers in. Where do you think they go? Okay, I want to see what you guys came up with. So enter it into the chat. You guys are doing awesome with this. I want to see more people participating. Not everybody's participating. If you can't find the chat box, remember, just put, your cursor over the top of the screen if you're on a computer. And then one of the things to click on up there is chat. There's participants. Right. So there's a lot more of you on here than are participating. So please participate with us. And if you're feeling kind of nervous and you don't want to, send it out to the whole class, remember, you don't have to send it to everybody. You can just send it to me. And that will be just fine too. Okay? Just want to Have some participation. All right, so everybody get that in there again. Round it to the nearest cent, right? That's what you're asking you to round to there. Okay, 3, 2, 1, hit enter. All right, I'm seeing a few different answers, so let's go through it and see, make sure we have this. And some of it is just the way you're putting it into the calculator too. So that's one of the things we gotta watch, right? So we're trying to find out what the end amount is. So we want to figure out what A equals. My principal this time is 5,000. So 5,000 should go there. And then 1 plus, remember my interest rate is 6%, so that should be 0.06 divided by, remember N is coming from this quarterly, right? And remember we said quarterly means 4 times a year. So that means I'm going to have a 4 there. And then raised to the 4 times 10 power. All right, so check first of all, is that the way you put the numbers in? Okay, then let's go down to the next row. So 5,000. And then some of you are going to have to do this division part first. So put 0.06 divided by 4 into your calculator and then add 1 to it. All right, and if you are putting it into your calculator just like this, you'll have to have a separate set of parentheses around that to show that you want to divide that first before adding 1 to it. Okay, but when you do that, you should get 1.015, and then round that, and then multiply the 4 times 10, so it's going to be to the 40th power. All right, and again, with your calculator, you got to make sure. So make sure you're not doing 5,000 times the 1.015 and then raise that to the 40th power. You've got to take your 1.015, raise that to the power, right? Because order of operations say do exponents before we do multiplication. Right? And when you do that, you should come out with the $9,070.09. Right? So that's what you should come up with. And remember, this is what you're ending up with. So you know that your answer has to be more than $5,000 because you already started, with $5,000 in there. So really, if we, thought of it like this, I'm just going to round it to the nearest dollar there. But if we were looking at this, right, and we were trying to figure out how much interest we've made, well, we've made $4,070 in interest because we put $5,000 in the account, right? And then just for sitting there, right, and not touching it for 10 years, you earned that $4,000 on there. So that's pretty substantial, right, to be able to come up with. All right, what questions can I answer on that one? And some of it's going to be just playing around with your calculator a little bit to make sure you know how to get to these numbers. Everybody's calculator is just a little different.
So on my calculator, I got 9,070, but I didn't get the 9 cents.
Did it not say anything behind there, or?
No, it just doesn't have the 9 cents. It's just 9,070, and that's it. 9,070 flat.
On the last one, did it give you any cents on example 1?
Yeah, it gave me the 25 cents. Let's see, yep. Because I got the last answer right, not the second one. Maybe I put it in a little, oh, I did put it in a little different. That's why. Never mind.
Okay. Yeah. So make sure you don't want to round. So if in your calculator you have to do this, raised to this power, let me just kind of like, if you're doing this part first, right, you actually get a really long decimal answer. Try not to round that answer. Like keep that whole number in there and then times it by 5,000. Because that will make sure that you come out with the correct number of cents there, because it usually will just change it by a little bit depending on if you round that. Okay, so just watch that. Other questions? Things I can explain on that? Some of you came up, there was quite a few of you that came up with the $907.01. How did you get that?
I put in 500 instead of 5,000. That was just my bad.
Oh, okay. Yeah, because I was sitting there because there was quite a few people that put that in. So
Yeah,
maybe...
that also happened to me.
Okay. So, yeah, I was like, wait a minute, what is happening there? Yeah, so yeah, just make sure, putting the correct numbers in there is half the battle, right? Probably more than half the battle on this one. So, all right. All right, let's do one where you're actually, let's do one if we're like dealing with like a house or something like that, right? So for this example,
I have a question actually real fast.
Yeah, of course.
How will we know will they like give us the equation when they're talking about like when they're subtracting the R instead of like, or the interest instead of adding it? Like, will they give us that?
So this is the same formula whether you're gaining interest or you're paying interest. But the other equation with depreciation, right? So these are really the only two formulas that you're going to have there. But it's just, so this one you're gaining interest because you know that, okay, I started with 5,000, now I have 9,000, so I've increased $4,000, right? But this next one that we're going to look at is where you're going to be paying interest, right, instead. But it's still the answer in the end is like how much are you going to be, So let's try this one. I think it'll help clarify, I hope. Okay, so let's see. You buy a house for $350,000. And mortgages are always, well, they usually are 30 years. You can do 15 years, but most people do 30 years to make their payment lower, right, per month. So you buy a house for $350,000, right, and you pay 4.5% interest compounded monthly. How much will you pay for the house if it takes 30 years to pay off the loan? All right, so again, right, we're going to use that same formula, that A equals P times 1 plus R over N raised to the N times T power. All right, so our principal this time, right, is that the price that we're paying for the home, right? So A equals, we'll have that 350,000 times 1 plus, well, our interest rate, okay, and I want to make sure that you're really careful with this. Remember, 4.5%, you're always moving that decimal back 2 places, right? So this is going to be 0.045, right? So be careful with that. So we'll have 0.045 divided by what? What is our N going to be this time?
Would it be 12?
Mm-hmm. Yep, it's 12 because it says it's compounded monthly, right? So that gives us our clue right there. So I've got to divide by 12. And then it's going to be raised to the 12, right? That's the number of times it's compounded, times 30 years. Right? Okay, so I want you guys to kind of simplify this up and then put it into your calculator. It's no different than the other ones, but now the amount that you're going to be looking at, right, is how much you'll be paying for the house overall. Instead of earning interest, you're paying it. Okay, raise your hand if you have an answer. Let's see where everybody's at being done. Okay, keep them raised, and then just press the hand raise button when you come up with an answer.
What does the exponent function look like on the calculator again?
Say that again.
What does the function or the exponent function look like on the calculator again? Yeah, TI-30.
Oh, this little, it's called a caret. It usually looks like that. But it could be that you have something like x to the y power on your calculator, or it might say like a box raised to a power. This looks different on all calculators. Do you see any of those?
No, I'm still looking.
What kind of calculator do you have?
TI-30.
Okay, it should be this little button right there. It's above the x squared button, usually.
All right, I found it. Thanks.
Okay.
Is compound interest different than regular interest?
Yeah, so simple interest means you're not making money on money, right? Or being charged money on the money that you already have. So, yeah, so simple interest just, it doesn't deal with the number of times compounded on here, and it doesn't have the, trying to see, simple interest is this. So you take your principal, times it by your rate, and times it by your time. So you're not raising anything to a power with simple interest. And so that power that we're dealing with on this is making that exponential growth, right? And making that amount go up really high, where simple interest won't get that high because it's...
So compound interest over time is more, because if you take the compound interest of your total amount of the loan that's due, it'll just keep adding every quarter or year.
Yeah, exactly.
Dang, that's messed up.
I know. It is crazy. Like I said, you want to earn compound interest, but it sucks to pay compound interest. But that's how most credit cards and most loans are. The only time you'd get like a simple interest loan like this is if you have like a family member or something that's like, I will loan you money at this interest rate. They usually don't compound it, different times, a year or something. They're not going to do that monthly, but otherwise loans are going to be compound interest for the most part. Okay, so let's see what you guys came up with here. Let's see if you came up with the same thing that I did. Okay, and if you didn't come up with this number, I want you to check a couple of things on here. Remember so if you have to put this in, like everything separate, you're going to start here. You've got to divide that, right? Keep that number in your calculator. Do not clear it out. Do not round it in any way. You only round on the very last step. Okay, so you keep that in there. You'll add 1 to it. Then you'll take whatever that number is and raise it to 12 times 30 is what? 360?
60.
Right? So you're taking all of that, raising it to the power of 360. Right? Hit enter and then times it by that 350,000. Right? So holy crap, look at this. Right? For a house that's worth $350,000, you're going to be ending up, if you don't ever pay you always pay the minimum amount on your loan, you're going to be paying over $1 million for that house. Right? And so that's why compound interest over time, right? The more time there is there, the faster that's going to go up. And so that's why a lot of people will try and do a 15-year loan instead, because it decreases this by so much. It's not by half, but it decreases it quite a bit there, right? But isn't that crazy, right? It's like, more than 3 times what you paid for it, you're going to end up paying over the life of the loan, right? So almost $1 million there is just interest. Are your minds blown? Oh my word, that's crazy, right? Cray. All right. Did everybody get that? Or do you... Just answer.
So I figured out why I couldn't get the sense on those problems before is because my calculator was in some sort of fixed mode.
Oh, okay.
I don't know when I turned that on or how it got turned on, but I figured out how to turn it off, and now I found the sense in my problem.
Oh, good. Good, good, good. Yeah. Sometimes that happens, that you just change a mode and it just will just round to the, you know, whole number or something like that. So yeah.
Yeah, because it looked like in fixed mode, it was rounding to the nearest like hundredth or thousandth. It was rounding to the nearest like degree in some number. But the fixed mode, if it's on for anybody else, is actually the period on my calculator. You press second and then period, and then press enter on the F, and it takes it out of fixed mode.
That's good to know. Yeah, because if you're not getting this number, you know, there could be a couple of different reasons for it. It could be in a strange mode that's not allowing, you know, everything in there, or it could just be the way you put it in too. So, okay. Everybody feeling okay on this? Speak up if you're not. Please, please, please.
So, random question.
Yeah.
You like made me nervous real quick with that big number and everything, and I just Googled it, and it says mortgage rates aren't usually compounded monthly though, and they're usually a simple interest rate.
Nope, they're not. Where did you get that from?
Google, and like the top 5 websites. It's usually the same.
No, when I look at my mortgage statement, everything is being compounded monthly.
Really?
Yeah. So that's how most of them are done. There's even some that are compounded daily. So I would look at that again because, yeah, that's usually the way it's going to be. But again, like I said, there's like ways, like you look at this number and you're like, oh my goodness, I'm never going to be able to do that. But if you tried to like pay just like, you know, $50 more, you know, each month, that's going to decrease that overall amount by so much. If you were able to pay it off in 15 years instead of 30 years, that's going to decrease it a lot. If you can get a better interest rate, right, and that depends on your credit history. If you have a good, you know, if you have good credit, you can get a lower rate than maybe 4.5%. And so all of those things kind of play into how much you'll pay for it over the life of the loan. But yeah, because that looks like, whoa, right? Insurmountable. How are we going to do that? But there's a lot of ways to get around that too. But yeah, but usually it's compounded monthly. So I'm curious what websites you're looking at there, because I've never heard of a mortgage not being compounded either monthly or daily. All right, let's look at just that. We're almost out of time, but this other formula, the depreciation one, isn't as difficult as the compound interest one. So I think if we do one example with this, we'll be okay. So what example are we on? In example 4, I think. So on this one, if we say a car purchased for $25,000 depreciates at a constant rate of 15%. Okay, and that's per year. Okay, what will be the value of the car in 5 years? All right, so usually people have like a loan. Oftentimes it's 5 years long for a car. Sometimes they'll have 6, but it can be anywhere in between there, 1 to 6 years. But by 5 years, you're kind of thinking, okay, well, how much, will my car be worth after I get it paid off? All right, so if I put these things in there, right, I'm trying to figure out the value of the car, so I'm trying to find V, and then I'm going to put 25,000 in place of my P, and then 1 minus, right, that 15%, remember, I've got to change it to a decimal, so 0.15, right? 1 minus 0.15, and then in 5 years, so raised to the 5th power. All right, so subtract these first, the 1 minus the 0.15, raise it to the 5th power, and then times it by the 25,000. Let's see what you come up with there. All right, we are pretty much out of time, so I'll put this up here and see if you guys come out with this same answer on it when you put that in. Like I said, this one usually isn't as difficult. All right, if we rounded to the nearest cent, that's what we got. All right, just make sure you're taking the 0.85, raising it to the 5th power, then timesing it by the 25,000. All right. All right, so it would be worth about 11,000 after 5 years if this was the depreciation rate of 15%. All right, and a lot of cars are a little more than that. Well, all right, questions? Comments?
When a story problem says constant, does that always mean, oh, just kidding. Does that always mean per year, though, if it says constant?
Yes.
Okay.
Yep, when it says it's constant rate, that's meaning, you know, it's decreasing by 15% each year. So it's not like 1 year it's decreasing at 15%, and then another year it's decreasing at 20%, and then another year 25%, right? Each year it's decreasing by that same amount. Hey, awesome. If you guys have individual questions you want to stay on and ask, great. Work on your homework of 6.1, 6.2, but make sure you first get done with Module 5 and get the Module 5 quiz and the retake taken if you want to do the retake. Okay? Let me know what questions you have. Have a great day.
Thanks, Becky.
Yep. See you guys.